For the next few days, we're going to be talking about research methods. In research, several pre-research decisions have to be made, and the first is in regard to the sample. The sample is the small group of participants out of a total number available that a researcher studies. For example, let's say a researcher wants to study college students. They're going to select college students from a few colleges versus trying to question every single college student in the world. And then what you'll see is that they will generalize the results that they gathered from a few college students to all college students. So there's a few things that a few characteristics that a sample must have. The first is that a sample has to be representative. So representative meaning it has to represent the population a researcher is studying. So again, this is going to help generalize results from the sample to a large group of people. The second is random. This means that in the sample, all individuals have to have an equal chance of being represented. So an example is choosing every 20th name off a school enrollment roster. That means that everybody in the school has the same, they all have an opportunity to be represented. Another example is if we think about using the telephone book and selecting, let's say, every 5th name. That could be an example of random, but then you get into the question of, well, not everybody, does everybody have a telephone? Does everybody have a home phone? So you could question, is that really random? But that might be an example of how we could do it in the United States versus, let's say, if you tried that same thing in India, there would be less likelihood that everybody would have a telephone and be in a telephone book, things like that. Next, a sample has to be stratified, meaning that the subgroups within the population that you're studying have to be represented proportionately. So let me give you an example. So let's say you're studying school children in the United States, and let's say 30% of all school children in the United States are ages 5 to 8. Then in your sample, that means that 30% of those studied will have to be ages 5 to 8. So for example, if you are studying 100 people, 30 of them would have to be ages 5 to 8 to represent school children. Another example is, let's say you're doing a study on the general population and you find that 38% of them are college educated, then that means 38% of your sample that's been randomly selected has to be from a college educated population. So let's say you have 100 people, 38 of them in that particular study would have to be college educated. So stratified just means that the subgroups are represented proportionally. So whether you're dividing your research by gender or social class or education level or religion, you have to represent proportionately. Alright, so here is going to be our first slide where you're going to practice. Now, we're going to be talking about more examples tomorrow, so just do your best. But you have to decide, are these samples representative or non-representative? So representative meaning of a whole population as a whole. Does everybody have an equal opportunity to be questioned? So the first one is, a person asks people from their church to participate in a study of family values. So representative or non-representative. Let's go back. So representative is representative of the population you're studying. Is it going to help you generalize results from the sample to a larger group of people? The second, a person chooses people shopping in an expensive store in the mall to respond to their survey. The third, a person asks their classmates to participate in a study of adolescent memory. The fourth one, a political campaign uses random digit dialing to contact people about who will win the election. So that just means random digit dialing is a computer chooses combinations of numbers and it just happens to call people. All right, so take a moment, answer that. So there are different methods of research that psychologists use. They choose which method that they want to use based on what's going to best help them to answer their research question. So today we're just going to be looking at experiments and correlational studies, and then in our next lesson we'll be looking at the other methods of research. So experiments, we've already talked about these a little bit, about how psychology is a science, they use experiments. Experiments are going to be a method in which psychologists develop a research question and use the scientific method to test it. So we've already gone over the different steps of the scientific method. Today we're just going to break down different variables involved in experiments and different groups in experiments. So we're looking at, in an experiment, there are independent variables as well as dependent variables. So the independent variable can also be abbreviated IV, is the variable that experimenters change to observe its effects. And I'm going to give you an example here in a moment, so don't worry if you're confused. Dependent variable is the variable that experiences changes caused by the other variable. Next, we have an experimental group. So this is going to be the group that's exposed to the independent variable. And then the control group is going to be treated the same as the experimental group, except they're not going to be exposed to the independent variable. All right, an example. Let's say, for example, a research question is, does taking a weight loss pill lead to weight loss? The hypothesis, if a person takes a weight loss pill, then he or she will lose weight. All right, so the independent variable, the variable that experimenters are going to change to observe its effect. The independent variable that they're going to change is giving the person the weight loss pill. The dependent variable, we have to see if there's going to be a change in the person. So dependent variable is, how many pounds are they losing from the pill? Experimental group is the group that is exposed to the independent variable. So this is the group that's going to be taking the weight loss pill. Now, we're going to get into this a little bit more when we look at problems with research. But the control group in this case, like it says, they're treated the same as the experimental group, but they are not exposed to the independent variable. Now, it's best not to tell which group they're in. That way they both believe that they're taking the pill. That's why in the control group, they're not going to be exposed to the independent variable in that they're not going to take the weight loss pill. They're controlling the situation. But so they still need to believe that they're taking a pill, so they would give them a sugar pill, but the people are not going to know that it's a sugar pill. They're going to believe they're taking the weight loss pill. So again, I'm going to give you, so that was your example. Use this example as you practice this scenario and just do your best. I know that this can be a little confusing and we're going to look at more examples, get more practice. So just do your best. Don't stress out about it. If you have questions, come with those. But this next one, you're going to identify the independent and dependent variables as well as the control and experimental group. So the question is, are workers with flexible hours more productive than workers with set work weeks? So for example, flexible hours meaning people can come and go as they please. Productivity is how much work do they actually get done. And then workers with set work weeks, that's like come in 9 to 5, 5 days a week, these 5 days, that type of thing. So the hypothesis is if a worker has a flexible work schedule, then he or she will have higher work productivity. Now take a moment, identify the variables, identify what the control group would look like and what the experimental group would look like. All right, the next type of research method that we're going to be talking about today is a correlational study. So if you'll notice in there, we see the word relational. So the purpose of this research method is to measure the relationship, so relational relationship between two variables. So we're going to be talking about positive correlations and negative correlations. So with a positive correlation, as one variable increases, the other one is going to increase as well. Or we can flip the arrow, so as one variable decreases, the other decreases as well. I know that you're thinking one arrow's up, those arrows are up and those are down, how is it still positive? It's still positive. So for example, the more you study for a quiz, the better grade you will get on the quiz. An example of this type of relationship. The less calories you eat, the less you will weigh. So those are a couple examples. Again, we're going to be looking at a lot more examples tomorrow. Next, looking at negative correlation. Negative correlation, you might also see it called inverse correlation. It's the same thing. So as one variable increases, the other is going to decrease. Or as one variable decreases, the other is going to increase. So some examples. The more time you spend on Facebook, the lower your grade. So we're assuming this is when you're supposed to be doing homework, that type of thing. An example of this type of relationship. The less time you spend on Facebook, the higher your grade. So we're assuming you're spending more time studying. So here's an example of the plot, what it would look like if it were plotted. So we see the hours spent studying psychology, you have a higher final grade in psychology. So if we were to put a best fit line there. Next, days absent from class. So they're saying the more days that you're absent, the lower your grade. So one arrow then would be up, one would be down. And then no correlation means that there's no relationship between the two variables. So this one is saying minutes spent brushing your teeth has no effect on your final grade in psychology. Alright, so what I want you to do now is go ahead and think of your own example of a positive correlation. And then think of your own example of a negative correlation. And then just like that last graph, think of two variables with no correlation. Now try to make this original. Don't just say, oh, well, the less time you spend on Instagram, the higher your grade. Try to think of something completely different from the examples that I gave you. And then the last thing that we're going to talk about is remember that correlation does not imply causation. So it can be really tempting to think that just because you see a relationship between two variables, that it means that one causes another. That is not the case. Just because there's a correlation does not mean that one variable causes the other. So, for example, let's say you get season tickets to watch the Red Sox play and they win every single game that you're at. That doesn't mean that you caused their victories. In the same way, another example of how correlation does not imply causation. Let's say every time you wash your car, it rains. So that would mean that you washing your car caused it to rain. Of course, that's not true. I know it's easy to think that there's a relationship there, but you washing your car has nothing to do with the weather. Another example, some of you are going to get upset by this one. Let's say you have lucky socks. Every time you wear them, you win. Reality is that there's no relationship there. All right, we'll finish research methods tomorrow.